Hello, my little warriors. Welcome back. Let's dive into question number 3 of chapter 8 trigonometry. And the question says if sin A is equal to 3 by 4, calculate cos A and tan A. We can solve this question in two methods. You can either solve it using Pythagorean theorem or you can solve using trigonometry identities. We will do with Pythagorean theorem because exercise 8.1 is based on Pythagorean theorem, and afterwards 8.2, 8.3, I think we can use trigonometry identities. But anyway, I'll show you the working of trigonometry identities also. You can use any method, still you'll get the same answer. I'll draw a triangle now. Okay, this is a right angle triangle. Now let's name the sides. Okay, now he says sine A is equal to 3 by 4. So sine A is equal to 3 by 4. So sine is basically opposite by hypotenuse. So if this is theta here, this is right angle triangle, this is 90 degree. Opposite, this is opposite, this is adjacent, and this is hypotenuse. Sine A. So we'll name this as A, B, C. So sine A is equal to 3 by 4. So opposite is 3. So opposite is equal to 3 and hypotenuse is equal to 4. We need to find the adjacent side. So using Pythagorean theorem, we can write AC square will be equal to AB square plus BC square. AC square is 4 square, that is equal to AB square we have to find out, plus BC square is 3 square. So 16 is equal to AB square plus 9. When 9 comes this side, it will become 7. 7 is equal to AB square, or AB will be equal to root 7. So adjacent side is basically root 7. So we got adjacent side as root 7. Now we have to find cos A. Cos A is given by adjacent by hypotenuse. So here adjacent is root 7 and hypotenuse is 4. So this is the answer for cos A. Tan A. Tan A is given by opposite by adjacent. Opposite by adjacent. So opposite is 3 and adjacent is root 7. So this is the answer for tan A, and with this we finish question number 3. Also, before we go into the next problem, I said that you can also solve this problem using trigonometry identities. So basically we have three identities. So we will use sine square A plus cos square A is equal to 1. So you know sine A is 3 by 4. So 3 by 4 the whole square plus cos square A is equal to 1. Therefore, cos square A is equal to 1 minus 9 by 16. Cos square A is equal to 16 minus 9 by 16. Therefore, cos A will be equal to root 7 by 4. This is cos A. And sin A, you know. So, you substitute tan A is equal to sin A by cos A. So when you substitute the values, you will also get tan A. This is using trigonometry identities. You can use any method, still you'll get the same answer. Let's go into the next problem. Question number 4 is given that 15 cot A is equal to 8. Find sin A and secant A. So first let's draw the diagram. We will solve this problem using Pythagorean theorem. You can also solve this using trigonometry identities, but we will solve it by Pythagorean theorem. First, let's draw the diagram. This is a right angle triangle. So E is given cot A is equal to 15 cot A is equal to 15 cot A is equal to 8. Therefore, cot A will be equal to 8 by 15. Cot A is basically adjacent by opposite. Adjacent by opposite. So here if this is theta, this is angle A, this is 90 degree. Opposite. Opposite of theta is this angle, this side. This side is opposite. Opposite is given 15 and adjacent is given as 8. Adjacent is this side. Adjacent is equal to 8. Now hypotenuse we don't know. You have to find. Okay. So this B C. AC square will be equal to AB square plus BC square. So AB square is 8 square and BC square is 15 square. That equals to 64 plus 15, 2 to 5. That equals to 289 will be AC square, or AC will be equal to 17. Root of 289 is 17. So this side is 17. So now we found the third side. Now just have to substitute the values. That's it. Then we get the answer. So they asked us to find sin A. Sin A is equal to opposite by hypotenuse. That equals opposite is 15 and hypotenuse is 17. That is sin A. Secant A is equal to 1 by cos A. That equals to 1 by adjacent by hypotenuse, and hypotenuse will come out. So the secant A will be hypotenuse by adjacent. Hypotenuse is 17, adjacent is equal to 8. So secant A is 17 by 8. And this is the working for this problem. And you can also solve this using sin square theta plus cos square theta is equal to 1, or you can use 1 plus tan square theta is equal to secant square theta. You can use any of this formula, then you can get the answer. Hope you understood the working of this problem. Now we shall go into the next question. Thank you so much. Now let's see the next question. The next question is, given that secant theta is equal to 13 by 12, calculate all other trigonometry ratios. We will also solve this using Pythagorean theorem. We can also do by trigonometry identities, but we will do with Pythagorean theorem. First, let me draw the triangle. Okay. Now he says secant theta is equal to 13 by 12. So, okay, secant theta is given by 13 by 12. Secant theta is basically 1 by cos theta. 1 by cos theta is equal to 13 by 12, or cos theta will be equal to 12 by 13. Cos theta is basically adjacent by hypotenuse. I already told this problem can be solved in two methods, either by using Pythagorean theorem or we can use trigonometry identities. But we will use Pythagorean theorem. Now, this is the right angle triangle and this is theta. Whatever side opposite to theta, that's the opposite side. Whatever side running along the side of theta is adjacent side or base. Adjacent is equal to 12, and this side is hypotenuse, that is 13. Now we have to find the opposite side. So if you name this is A, B, C. So AC square will be equal to AB square, AB square plus BC square. That equals AB square is 12 square plus BC square is, we don't know, and AC square is 13 square. So 169 is equal to 144 plus opposite, that is BC square. So 169 minus 144 will be equal to BC square, or BC square will be 25 and BC will be equal to 5. So BC is basically opposite side. Opposite sides is equal to 5. Now we know all the sides. You can just write the trigonometry ratios one by one. Let's start with sine theta. Sine theta will be opposite by hypotenuse. Opposite is 5 and hypotenuse is 13. Cos theta is already found, which is 13 by 12. Tan theta will be basically equal to sin theta by cos theta, or opposite by adjacent. I mean mistake here. Cos theta is 12 by 13. 12 by 13. And therefore 5 by 13 divided by 12 by 13. 13 that gets cancelled. So cos theta, tan theta will be 5 by 12. Cot theta will be 1 by tan theta, that will be 12 by 5. So we had secant theta already given. Secant theta is 13 by 12, and cosecant theta is 1 by sin theta, so which is basically 13 by 5. So we found all the ratios, and we can also solve this using trigonometry identities, using the formula 1 plus tan square theta, 1 plus tan square theta is equal to secant square theta. But I'm not going to do that working, because trigonometry identities will start working in exercise 8.3 onwards. Okay, let's see the next question.